Welcome back, everyone. In this lecture, we're going to discuss two built-in modules. One is the math module. It's essentially just a module that holds a ton of useful math functions. We won't go through every single one, but we'll show you how to find them. And then there's the random module that contains a lot of mathematical random functions, as well as random functions for grabbing a random item from a Python list. We've actually already seen a little bit of random with random shuffle, but let's explore these in more detail. You can check out the links in the lecture notebook if you're looking for a link to the documentation online, or you can just Google search math Python module and your first link will be the official documentation. Let's head over to a Jupyter notebook. All right, here we are at the Jupyter notebook. Let's go ahead and start off with the math module. Going to import math. And if you want to figure out what's available to you in math, you can actually just call help math, and it'll describe that this module is always available and essentially has a bunch of mathematical functions available. It's everything from trigonometric functions like arc cosine or hyperbolic cosine or inverse hyperbolic cosine, all the way to simpler things like taking the floor of a number, essentially just taking the largest integer that is less than or equal to x, and so on. We're going to explore just a couple of these functions, and the rest I'll leave it up to you if you ever need them to just look it up in the documentation. But just always keep in mind that if there's a basic mathematical function that is common enough to be found in any mathematics textbook, it's probably available to you inside the math module. You just need to say from math import whatever function you're looking at, or just call math.function. So let's go ahead and check this out. So let's see how we can round numbers. If we have a value called 4.35, for instance, there's a couple different ways we can do this. Using the math module, I can say floor, which essentially is going to bring this down to the integer that is less than or equal to the value. So that should be 4. And then I can do ceiling. So if I said math.ceil for ceiling, it essentially works the other way, giving you the next integer up. So it essentially rounds up regardless if it's closer or not to that floor value. If you want essentially a true rounding, so you can call round. It's actually built into Python itself. It's not part of the math module because it's common enough to use. So if you just say round 4.3 or 4.35, since it's closer to 4, it will round it down. And if you do something like round 4.5, which is kind of right in the middle, it'll go to 4. But notice what happens if I say round 5.5, it goes to 6. So what's actually happening here? Why is one going down and one going up? It's because in general, you want to choose to always round to either all evens or all odds when you're starting to, for instance, create some sort of set of rules. And the reason for that is if you always chose to round down when it came to a 0.5 split, something right in the middle, then all your estimates over time would be lower than they should be. Or if you always chose to round up, then over time, all these rounding errors would be higher than they should be. If you choose a rule based off a number being even or odd, then you start to even itself out because you'll round down as many times, hopefully, as you round up. So that's why you'll see this round at 0.5 go towards the even numbers, like 4 and 6, when it comes to some split right down the middle. Okay, let's show you how you can grab mathematical constants. So you can call these right off of the math library, such as mathpy, and that gives you the mathematical constant pi, or if you want, you can say from math, import pi, and then just use something like pi in your code. There's also e, very common number, and there's representations of things like infinity or not a number. So math, infinity, or math, not a number. Something I also want to point out, if you find yourself that you're working with heavy enough mathematics that you're going to be using math.infinity or math.not a number, you may want to check out the NumPy library. That's NumPy. Check it out online. It's a library specifically designed for numerical processing, and it's highly efficient and goes much deeper than Python's built-in math module. But for our use cases in this course, the math module is more than enough. Finally, let's go ahead and see how we could do logarithmic values with the math function. So here we have math e, so we have 2.71, and if you take the log base e of math e, it should give you 1. So what does this actually mean? Essentially, it's just the base to the power of some n is equal to the variable you provide. So let me show you this by showing you how to create a custom log base. So I will call math.log you'll notice it provides an x, and it's up to you to provide a base. Return the logarithm of x to the given base. So if I say 100 is x base 10, it returns back 2. So what is that actually solving for? It's solving for what number do I have to take 10 to the power of in order to get 100. So that means I'd have to do 10 to the power of 2 to get 100. So if you're not familiar with logarithmic, just mathematics in general, then you probably won't be using this in Python anyways. And finally, there's trigonometric functions, another really useful one. You can take math sine of some number, it returns it back. In radians, if you want to turn it into degrees, you simply say math.degrees. It can convert something from radians into degrees. For example, pi over 2 in degrees is 90 degrees. Or math radians, 180 degree in radians, whoops, make sure we spell that right, is going to be equal to pi. Again, that's just basic trigonometry, and that's all within the math module that's built into Python. Let's move on and discuss the random module. The random module allows us to create random numbers, and we can even set a seed to produce the same random set every time. Now, an explanation of how computers attempt to generate random numbers is really beyond the scope of this course because it actually involves some pretty high-level mathematics on how computers use what are known as pseudo-random number generators. Now, I've linked 2 Wikipedia articles in case you are interested in this in the lecture notebook. So if you check out the lecture notebook, let me bring it over real quick. When we discuss the random modules, there's 2 useful links here. One is discussing pseudo-random number generators. It's a really interesting field of mathematics, really interesting history on how you can actually get a computer to show something that looks random, as well as random seed, which is then how can you get the same batch of random numbers if you want to test the same code over and over again. So let's go ahead and start trying to understand a seed. Let me bring this back over here. To begin, I'm going to import random, and let's start by checking out the random.randint. So if we check out what this function does, it just returns a random integer in range a and b, and it includes both endpoints, which means if I type in right here 0 and 100 and run this, it's going to return back some random integer. If you ran this, it's more than likely than not that you got a different number than I did. It's basically a 1% chance that you got the same number I did. And every time you run this, you'll notice you start getting back a different random integer. It's possible that you get the same one in a row, but that's 1 over 100 times 1 over 100 chance. Okay, so we know we can produce random integers. However, what if I'm testing a code script and I want to make adjustments to this script of code, but I want to test it on random numbers, but the same batch of random numbers? This is where the seed comes into play. Setting a seed allows us to start from a seeded pseudo-random number generator, which means the same random numbers will show up in a series. Okay, when it comes to running this within Jupyter, in order to make sure this works, your seed should be in the same cell as whatever function you're using to generate random numbers. So we call random.seed, and then it's up to you to choose some seed value. Note, this value is completely arbitrary. It can be whatever you want. Often people do 101 just because it's easy to remember and it looks nice. Other times people, especially libraries, often use 42 because of Hitchhiker's Guide to the Galaxy. It's just a reference to that. But again, this value right here is completely up to you. It's totally arbitrary. So we choose that seed, and in the same cell, what I want you to do, if you're following along with me, is call randint, and then 0, 100. Go ahead and run this, and if you set this up, both for the seed, the same value I did, you should have gotten the same random integer if these were in the same cell. So notice here, we get back 74. And note what's going to happen. I'm going to run this again one more time. Again, I get 74. It doesn't matter how many times I run this cell, I always get back 74 because the seed's set. And the seed essentially starts the same series of random integers. So if I copy this and paste it in the next cell, if I run this, I will get 24. And if I run this one, I'll get 69. However, let's go ahead and reset our seed. Notice now all 3 cells keep repeating those same random numbers. But if I take one of these and I haven't set the seed or reset it again, and I keep calling this one, I'll get the same series of random integers. each time. So essentially what that means is if I were to print these out, let's go ahead and copy and paste this a couple times. Let's print this out 5 times, and we'll reset the seed within this cell. What I should expect is that this first one produces 74, and that this next one produces 24, since I can see right here that it goes 74, 24, and I believe the next one was 69, and so on. So when I run this, I get back those results, 74, 24, and 69. And that's because I set the seed right before calling that first random integer. So the thing I really want to clarify here is just because you set a seed doesn't mean that every time you call random integer, it'll always return 74. Instead, you should think of it as setting a seed for any sequence of basically infinite random numbers. Okay, so we already know that we can grab random integers using the randint function. There's a couple of other functions I want to show you with the random library. The first one I want to show you is taking just a random item from a list. So I can say my list is equal to list range 0 to 20. So now I have a list of a bunch of integers, 0 up to 19. And let's imagine I wanted to grab just a random item from this. I could say random.choice, my list, run this, and it chooses some random integer from this. In this case, it was 16 for me. Keep in mind, this does not permanently affect your list. 16 is still there within your list. Now, that's just for grabbing one item. Let's imagine you want to grab multiple items. Let's say I want 5 random numbers from this list. Well, there's 2 different ways of doing that. One is to allow yourself to pick the same number twice. So that's sampling with replacement. Or you sample without replacement. Means once you've picked out an item from this list, you can't pick it again. So let's show you first sample with replacement. So again, that's going to be allowing the same integer in this case to be chosen more than once. And the way that works is we call random.choices. And there's 2 main parameters here. It's the population, what you're actually picking from, which is my list, and then k, which is how many items you want from this. Let's make k equal to 10. So that means I'm going to randomly pick a number from this list. I'm going to do that 10 times, and it will return a list of those numbers. Since I'm sampling with replacement, I should be able to see some numbers duplicated. And with k equal to 10, it's highly likely that you picked the same number at least twice. So here we can see 4 was chosen twice, as well as 1. Actually, 4 was chosen 3 times. Okay, so that's sampling with replacement. Now let's imagine I want to sample without replacement. So what does that mean? It means that once I've chosen a number, I don't get to pick it again. And to do that, that's going to be random.sample. Same parameters. We provide a population, my list, and if I say k is equal to 10, we run this. Notice that none of these numbers are repeated, because once you picked it, you're not allowed to pick it again. Okay. Finally, we can show you how to shuffle a list. Keep in mind, this will permanently affect the list, so you don't need to actually assign the result to anything. So here's my list. If I wanted to shuffle it in place, I can say random.shuffle, my list. No, I do not do any sort of reassignment. It just does it in place. So the list is permanently affected. And in case you're interested in probability distributions, there are a few that are available to you in the random library. So there's a uniform distribution, in case you're familiar with it, which is essentially just going to randomly pick a value between A and B. So let's say A is equal to 0 and B is equal to 100. This is a continuous distribution, so that means floating point numbers are allowed. So it can pick any number between 0 and 100 up to a very large floating point precision. So it's not just integers. So you run this, and in this case, I chose 0.65. And the reason that it's called uniform is because every number between 0 and 100 has the same likelihood of being chosen. Now there's also a normal or Gaussian distribution that you can choose. So that's callable by random.gauss. And this takes in a mean and a standard deviation. If you're not familiar with that, then don't worry about it. You probably wouldn't be using this if you don't know what a normal distribution is. But in case you do know, you should be aware that it is available to you within Python's built-in random module. This is a Gaussian or normal distribution centered at 0 with a standard deviation of 1. We run that and it picks just some random value from that. So something I want to know is if you're using Python to the point where you find yourself calling uniform random distributions or random normal distributions, you should really look into the NumPy library. We teach it in some of my data science and machine learning courses. You can check it out there, or you can just check out the free online documentation. It's a really powerful library, and I would highly recommend that if you're calling random.uniform or random.gauss, you just start switching over to NumPy at that point. Okay, thanks, and I'll see you at the next lecture.